Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to look at solving age word problems. So you're probably going to be encountering word problems that involve ages, present ages, future ages, and previous ages. And with these kinds of problems, I think a really good strategy is to set up a chart. So your chart will have the people on, the left column. So I just made up Jack and Jill. You're going to probably have present age as a column. And you're going to have, a future or a previous age as your next column. So 5 years ago or 5 years from now. And they'll probably tell you something about one person's age in terms of the other person's age. So let's say that they said Jill was 2 years younger than Jack. So if we said Jack was X years old, that means Jill would be -2. So you always want to express the other person's age in terms of the variable that you choose. And then what you want to do is have an expression for their ages in that future time or that previous time. So 5 years ago, how old was Jack? Well, Jack would have been X minus 5. How old would Jill have been? She would have been X minus 2 minus 5, which you could simplify. And if we had in 5 years, Jack's age would be X plus 5, and Jill's age would be X minus 2 plus 5. So you always want to express everything in these chart in terms of just the one variable. Once you have that, you can then look at other information that's in the question and come up with your equation. Let's take a look. So in this example, it says Niles is 3 years younger than Fraser. 10 years ago, the sum of their ages was 67. What are their present ages? So we could let N be Niles' present age. And if we did that, because Niles is 3 years younger than Fraser, then Fraser would be N plus 3. You could do the other way. You could have F represent Fraser, then Niles' age would be F minus 3. So you can do it either way. Then it says 10 years ago. So 10 years ago means in the past. So if Niles' present age is N, 10 years ago, his age would have been N minus 10. Fraser's present age is N plus 3. So his age 10 years ago, just subtract 10 from his present age. Now that we have both the present age and the age 10 years ago for both Niles and Fraser expressed in terms of one variable, we can then look at the rest of the word problem to get what other information we haven't covered yet that will create the basis for our equation. So 10 years ago, the sum of their ages was 67. That's the information we're going to use for our equation. Niles' age 10 years ago plus Fraser's age 10 years ago. Sum means addition is 67. We could have simplified this to N minus 7 before we started. I'll do that now. So I can take it out of the brackets. I'll just do that. But I could have done that before this. I could have gone N plus 3 minus 10, which is just N minus 7. So do it, before you start the equation, or do it when you're doing the equation. It's your choice. Now we solve the equation. N plus N is 2N. We have minus 20 plus 3 would be minus 17. Just adding my like terms. Now I'm going to add a 17 to both sides. So I'll be left with 2N equals 84. And then I divide both sides by 2. And I get a solution of 42. If Niles' age is 42, that means Fraser must be 45. So let's check. So 10 years ago, Niles would have been 32. 10 years ago, Fraser would have been 35. Do those two ages add up to 67? Yes. So we've checked our result, and then we look to see what the question asks. It wants both answers, or both ages. So Niles is 42 years old, and Fraser is 45 years old. And we've solved the question. Okay, let's take a look at this next word problem. It says Marge is 4 times as old as her daughter Lisa. 5 years ago, Marge was 7 times the age of Lisa. How old is Marge? So a lot of numbers happening, a lot of information. And if you have a chart, if you use a chart, it takes a few minutes extra to process or to set it up. But it sort of organizes all of that information. So in this case, I started the chart already. We have 2 people, Marge and Lisa. It talks about their present ages, if Marge is 4 times as old as her daughter. So that's the present ages right now. And then it talks about 5 years ago. So those are our 2 columns. Now we can either let our unknown equal Marge's present age or Lisa's present age. Because Marge is 4 times as old as Lisa, I probably would let my variable be Lisa, because then I can express Marge's age as 4 times that. If I do the opposite, I'll have to get into fractions. I'll have to say that Lisa is 1/4 the age of Marge. So if I'm going to let this be my unknown, I'm going to let it be L, just to remind me at the end that it was Lisa's age, not Marge's age. And if Lisa's L years old, Marge is 4 times that. So Marge will be 4L. Okay, so 5 years, we won't even look at any of this information. We know we want it 5 years ago, so we'll not look at that yet. What we want to do is express what Marge's age was 5 years ago. So if her present age is 4L, 5 years ago, she will be 4L minus 5. Similarly, Lisa, present age is L, so 5 years ago, she was L minus 5. Now we look at the word problem. Any information we haven't used yet, that's going to create the basis for our equation. So that's going to be this statement here. 5 years ago, Marge was 7 times the age of Lisa. So I'm going to be working with these ages here. 5 years ago, this age is 7 times this age. That's our equation. So Marge's age 5 years ago, 4L minus 5, will be equal, was means equal, 7 times the age of Lisa, and Lisa's age 5 years ago is L minus 5. So hopefully you can see what we're doing, get your information in a chart, and then take this information in this column that talks about 5 years ago or in 10 years or whatever it is. That's what you're going to use with the rest of the information in the words to set up your equation. And now we'll solve. So I'm going to subtract 4L from both sides. So that will be 3L. I'm going to add 35 to both sides. And I will get negative 5 plus 35 is 30. I'm going to divide by 3. So I get L equals 10. Let's figure out what Marge's age is, and then let's do a check, and then let's answer the question that the problem asks. So if Lisa is 10, Marge is 4 times that, so Marge must be 40. 5 years ago, if Marge is 40 now, 5 years ago she would have been 35. If Lisa is 10 now, 5 years ago she would have been 5. Is 35 7 times 5? Yes, it is. So we've made sure that all of the requirements or information in the word problem have been satisfied. And now we're going to answer the question, how old is Marge? So Marge is 40 years old. Okay, this time we'll do the question, and I won't start with the chart partially filled in. We'll start at the beginning and I'll fill it in with you. So this question says, Jesse is 25 years younger than Walter, and in 4 years, Walter will be twice Jesse's age. what are their ages. So we have two people. We have Jesse and we have Walter. They're talking about their present ages because he says right now, Jesse, it doesn't say right now, but that's the assumption. Jesse is 25 years younger than Walter, so we assume that means right now. So that's the present age. And then in 4 years. So that will be our last column. So they're talking in the problem about their present ages. They're talking about their ages in 4 years. So if Jesse is 25 years younger than Walter, I'm going to let J be my unknown that I'm going to use, and it's going to represent Jesse's age. So J for Jesse, because it's easy then to write Walter's age in terms of that. Addition is always easier than subtraction, not a big deal, but a lot of students find they make less errors with addition than subtraction. So if Jesse is 25 years younger than Walter, that means Walter is 25 years older. So Walter will be J plus 25. Okay, that's their present ages. But in our equation, we're going to be dealing with this statement, which talks about their ages in 4 years. So Jesse's age in 4 years will be J plus 4. Walter's age will be J plus 25 plus 4, which is simply J plus 29. So we'll use that in our equation instead of that. So now that we've got their ages in 4 years in terms of our one variable, we can set up our equation. In 4 years, Walter will be twice Jesse's age. So Walter's age in 4 years, which is J plus 29, will be, that means equals, twice, that means 2 times, Jesse's age in 4 years is J plus 4. I think the biggest mistake that students make with these age questions is they use Jesse's present age. They forget to add the 4 years or whatever the problem is to the present age of that person, and that's where a lot of people make mistakes. So remember, this chart will help you include that 4 years or whatever the problem is in both ages. So now we solve this. J plus 29 will equal 2J plus 8. I'm going to subtract a J from both sides. 2J minus J is just J. I'm going to subtract an 8 from both sides. So Jesse is 21. And let's find Walter's age then, and then let's check everything. So if Jesse is 21, Walter is 25 years older than that, so Walter will be 46. And in 4 years, Jesse will be 21 plus 4 is 25. Walter will be 46 plus 4 will be 50. Is this twice that? Yes, it is. So I know that it's correct, and now we'll answer the problem. What are their ages? So Jesse is 21 years old. And Walter is 46 years old. You would give their present ages. So there's a pattern. The chart will probably be useful. I would recommend you work on some age problems. They might be slightly different than this, but don't try to do all of the information in the chart. Just have a column for their present age and then a column for their age in the past or in the future, whatever the problem talks about. And then look at any other information, whether it's the sum of the ages, in that many years or so many years ago, one person was this many times older than the other person. Leave that information for your equation. Practice these, get comfortable with them, get confident with them, and then when you're ready, you can take a look at the next video on word problems and get started with a new category of word problems. Until then, take care.